Welcome to another Tech Explosions podcast. In this episode, my guest is Daniel Cao, one of the founders of EIM Technology, a company dedicated to creating portable electronics laboratory devices for makers and educators. Daniel grew up in China and moved to Canada when he was 19 to study systems engineering at Simon Fraser University. He became deeply interested in hardware and electronics, and after graduation, he spent another 2 years towards a master's degree in biophotonics. Around that time, he founded EIM Technology with several colleagues from his lab. At EIM Technologies, the vision is to lower the barrier to entry into the worlds of electronics for everyone. Towards this vision, the company designs and develops convenient, affordable and accessible equipment, tools and kits such as the Zulac portable multifunction instrument and the Mego portable power supply. In today's discussion with Daniel, we'll talk about these devices and EIM's plans, including their upcoming FPGA board project and Kickstarter campaign. So Daniel, thank you for joining me in this podcast. How are you today?
Yeah, I'm pretty good. How are you?
All good, thanks. It's a nice cloudy day here in Sydney, and I believe you're in Beijing, 8 o'clock in the morning, right? How are things there?
Yeah, that's right. Well, I have pretty much the same weather with you.
It's cloudy. Northern hemisphere, southern hemisphere looks like the weather is doing the same thing today everywhere. So so we've got quite a few things to talk about. Like we've been corresponding on and off for the last couple of years. I've been using some of your hardware. I spent a lot of time working with your first generation FPGA board and then the Zulac. I've posted a couple of comprehensive posts on our website. But this time we thought let's get together and talk about EIM Technologies and your vision for the company, your role in education, technology education in particular, some of the upcoming products as well, because I think you've got a few interesting things coming on like this year in particular. And I'm sure your vision for the future is actually very exciting. So maybe start with a little bit of history. Tell us a bit about the company, how it started, and what really motivates EIM Technologies.
Well, yes, absolutely. Well, first of all, thank you for you and your audience giving me this opportunity to introduce a bit about myself and my company. Well, actually, I started up EIM Technology well back while I was in graduate school with some other of my folks in the lab. So at that time, we didn't have, not have actually a clear mission or business plan, but rather we just get together, like we want to invent something together, like useful gadgets together. So thanks to my all partners, like our team, we don't have, much funding for that at the time, but was kind of a very collaborated, and we kind of are putting actions, very quickly. So our first product was Mego. As you can see, this it is a portable power supply, meaning for breadboards. It has adjustable output voltage, and you can see the pin headers here, which is directly compatible to a breadboard, where you can just simply plug it onto a breadboard. It gives a power rail. So instead of connecting a lot of wires, which might be a little bit painful for the students when they first get to learn the breadboard, you use this kind of a neat thing and put it all together. Boom, you have electricity to juice up your circuit. So this is what I initially designed with our team. What a bit funny is initially I got this one not aiming for a product. It's because while doing my research, my concentration was in biophotonics. So as an engineer student, I used to work with other teams such as like a biology and health science stuff. So at that time, I used to carry like a 20 pounds power supply, with lots of instruments all over the campus, which is kind of painful for just doing simple electronics experiments. So at that time, I just simply built some circuiting. It's not like a product yet. It just built some circuit modules, put here and there, use some stick wires stuff. And all those folks seems, oh, why don't you turn that into a product? Because it's kind of useful, right? You don't have to bring that heavy duty machine every time. So at that time, I call up the folks, say, okay, since we have expertise, we know how the engineering works, we have some connections with the manufacturing. So we just turned that into a real product. So a few years ago, we got this design after like probably like 10 rounds of revisions. We finally got a 3D printed version, and we put that on Kickstarter. And fortunately, we got that succeeded. So we have the initial funding to launch a production and collected a bit of customers who love our products. Then we have the some initiative to continue as a business.
Right. So the origin story that you just told us about Mego is basically you had a personal need and you built something to satisfy this need, and this product came out of it, which is like, yeah, that's how it's done very often. I was just looking at Mego on your website and just realized, I didn't realize it previously, but it's got a battery built in, which means, I think that's what you mean by portable, not just that it's small, but it's also self-sufficient. So you don't have to plug it into a power supply or a power socket. The battery can supply power for your project.
Yes.
Great.
Well, actually, we had a debate in the beginning saying whether we need a battery or not, because, as micro USB or Type-C is also kind of a convenient. But in practice, sometimes, today you have a computer, but you always get your USB ports plugging here and there. Lots of so many stuff requiring the USB from your computer draining energies. So I think, well, why don't we just add a battery, lithium battery? We can make it a purely standalone device. Since it's a power supply, it's not like some other devices. It gives power to other stuff. So the power is crucial for itself. So after some debate, we decided to put a lithium battery with a 2000 milliamps hours. So that is kind of a sufficient for a whole day usage if you are doing some circuiting design.
Yeah, great. So that happened, if I know correctly, in Canada. That's where you were still studying at the time, right? You were doing your photonics.
Actually, I finished my master's degree, I think, to be accurate, 2 years ago. So actually, you got a question. So after I graduated, while you were students, you don't have to worry much about the future career because you were focused kind of your research and study. But, after we graduated, there was a decision for us, right? So we either have to, we either decided to go to continue our business as a career, or we just say bye to each other, folks, and we seek for our own jobs, which just seems to be more predictable actually for us. But, as a decision, we still come together and continue our business as for our career for now. So our objective was getting more and more clear after we put Mego into as a real product, because we saw a faster growing market in STEM education, right? STEM is, everybody knows STEM is like a science, technology, engineering, and mathematics. It's drawing a lot of attention from the young generations and the government and society as well. So our focus is particularly in electronics, hardware, and technology. And we also evaluated our own expertise and strength for the team. So we decided to focus on this design and development of STEM-related tools, equipment, and also the kits that can significantly lower the barrier of new students or beginners to either find something curious. And also we would like to bring some convenience to the educators and the teachers so they find great tools while they teach students. Yeah, that's basically our mission of the company.
So I'm curious here, Daniel. So I understand you did photonics after an electrical engineering degree, and I guess you were in an electrical engineering lab. Did you have any educators within the peers that you worked with, just to give you some insights into how STEM works? And like, for example, what is the experience of a STEM teacher in a school lab? Or did you research all that as you were trying to figure out, as you said, what should this company be all about after you developed Mego as your first product?
Yeah, you got an absolutely great question. Because initially, when we designed Mego, our target audience is mainly for makers, hobbyists, right? We didn't think of that can be applied for STEM education market. But since our team did some research, for example, our team is in Vancouver, British Columbia in Canada. So we did a research for the high school curriculum for the entire British Columbia province. And we just realized that since 2019 or 2018 or 2019, they add a whole bunch of electronics, robotics, hardware topic in their high school. So high school means they're going to study electronics since grade 9, 10, 11, and 12. So probably 4 years. So at that time, something came into my mind because, high school is not like universities where universities can afford a designated lab room with probably like a 50 professional lab, benchtop lab equipments for each student to use. But in high school, when you learn the stuff, well, I don't think they have those many equipments having all the students to make hands-on experiments. Well, as a hardware engineer, you cannot learn electronics and hardware without actually doing things, right? So I think, for example, if using our product Mego as an example, well, they can simply build a breadboard circuit without using a benchtop level power supply, right? To just do some simple experiments. So I decided, why don't we just introduce our product to some high school students and teachers? And yeah, we actually get in touch with some teachers, and they were quite interested in that. We even got a few high schools just bulk purchase our products and deploy the products to their entire high school, maybe like 100 or 200 students. So I think, yeah, that can be exciting and having some potentials. We also know some other STEM agencies, for example, they are not necessarily in the school curriculum, but rather more like an interest-based, right? They build some Lego stuff and also some, hand working related to robotics and some cool gadgets. I say, well, before all of the stuff you build is more like a mechanical, structural, right? But why don't you just add our products, which look simple and kind of a cute, easy stuff, so that you can make more electronics topics into your course to make your curriculum or your course more competitive and more diverse. And I think a lot of STEM educators, they agreed this idea on me. So that's why they say, oh, the one power supply is not enough. Why don't you just go and design some function generator, oscilloscope, all those kind of stuff? I think, oh, wow, you have a good idea. So that's why we go ahead and, spend probably 1 year focus on the Zulark design. And that's why we came up with the Zulark. As you can see, this small piece here, a lot of people, you got it. A lot of teachers, they say, I want them to be small and I don't want many equipments there. I just want to have a single unit. It doesn't have to be very sophisticated, but it's good enough for students to do some experiments, understanding what is Ohm's law, what is AC signal stuff. Say, okay, I put all of this as like a functional specifications, and then we go ahead and launch this product. Well, I know we still got some complaints say, well, why don't you make that so small? Or you add this function, that function, but that's also give our motivation to make future improvements. But that's what we got as a first initial kick.
Well, so you started this like a pure selfish reasons, I guess. You're solving your own problem as you were going around labs in university during your degree. That's your first product. Then you find your way into education. You identify STEM education as a growth area that is underserved, at least. Your comparison between a lab situation in a university versus a lab situation in a school is actually spot on, because I've experienced the exact same thing when I went from my school to university. It was just day and night, from no equipment to every student having an expensive suite of test instruments in front of them to use. And you wanted to create something that could be used at the school level, that would be portable meaning small and self-sufficient. You don't need to connect it to other stuff to work. Affordable, of course. And you started producing products to fill this niche. And I think now you've got a vision in EIM Technology about what these products would look like and how you can best use your skills as designers of products to make it easier for students and for teachers to do electronics in a STEM context, which I think you also nailed it really well, which means combine knowledge from different areas like mechanics with electronics and programming, for example. That's what STEM is all about. So all these combinations is what produces results and hands-on lab experiences. So I guess just to progress the discussion a little bit, maybe I think we should focus into those products now, because I think that by looking into your products, we can get a better understanding of how you think and how you are planning for the future as well. So maybe take a step back and go from Mego, or Mego, I think you call it Mego, I call it Mego, but let's go with Mego, since you're the founder. I think after that, and I may have my chronology incorrect, but I think you built you designed an FPGA board after Mego. Is it correct?
Yes. Well, FPGA is another, topic we want to cover, because, initially we want to do something on microcontrollers, but, I'm also a fan of Arduino. I think there isn't much learning barriers for Arduino, especially, for example, you see Arduino, especially seeing lots of Arduino projects, even in high school, right? And it means that there is no problem for people or beginners to learn Arduino in their first step, because it is so well established. I would say it's so well-established the ecosystem built by Arduino itself, and also millions of contributors and hardware, open source hardware hobbyists in the world. So you can basically practically find any example or projects with very detailed instructions and nice documentations, basically covering all the topics for the entry level. So in this case, I don't think we need to do anything on the microcontroller side. But at that time, we think FPGA is another crucially important topic in electronics and hardware. But when you learn FPGA stuff, it's kind of a FPGA is more designed for advanced applications for people with sufficient knowledge in electronics and skills. For those people to learn FPGA, they may still have some issues, but so not to mention for the beginners, it's kind of you don't have places to find lots of learning examples, and the board itself takes probably a few hours to just configure itself. So we need to lower the barrier of FPGA. Yeah. So that's why you created the first FPGA board. I think that's when we actually got in touch and virtually met. You approached me and you said, "I've got this, check it out," and I did. Of course, yes. I knew what FPGA was, but I never took the time to learn it, because I felt the same thing as what you described, that it was quite a difficult topic, and I didn't want to get bogged down with it because I had other things to do, literally. So, but with your board, which is this board here, and for the first time ever, I did get into playing around with FPGAs, and I did actually learn thanks to the board. And
there's an analogy here, like this board from EIM Technologies seems to be like the Arduino Uno of the microcontroller world in terms of a simple to use board that you can program relatively simply compared to what else is out there in the education space for FPGA. And I think this is where you put in practice your philosophy of trying to simplify things in the electronics world. This is a board that can be used at the school level, right? Of course, it could be used at the university level, but this can definitely be used at a school level to teach people at high school, or kids at high school, how to build an FPGA application.
Yes,
and,
exactly.
This is just my write-up. Basically, this is a brain dump of what I learned as I was playing with your FPGA board. It's quite detailed, a lot of knowledge there, but it took me a couple of weeks to do this.
Well, actually, you've been written a excellent tutorial for the beginners, and a lot of people, they ask me if there is appropriate documentation or some other body share some learning experiences. I always send this link to those people saying, well, you just look at this very detailed learning process. You get a sense how this FPGA could be simplified, and it's not really that painful for you to learn FPGA as an absolute beginner, because a lot of Arduino or other electronics hobbyists, when they get to a certain level, they're being more curious. And we've been heard of FPGA so many times, especially during the time where, well, like Bitcoin mining is popular, right? They heard of FPGAs sort of being there, and autonomous driving, high speed, virtual reality stuff. All those stuff must require FPGA because they need very concurrent, fast processing and calculations, computations, right? So they want to learn some FPGA stuff. But at the first beginning, as you said, it is mainly FPGAs were built for very advanced applications and high-end users. So there isn't much, beginner kits for the new learners to start. So what we did is we make that to be small, and then you can just plug in onto a breadboard as like a Arduino Nano maybe. Yeah. Also, we later on we made some further improvements, which is even more easy to use than the board you received, which is our version 1. So later on, we built entirely compatible integrated development environment, IDE, which you can just go to the internet. You don't have to download anything. You just go to internet, put email account to register, and then you start from designing Verilog, assigning all the pins with the graphical stuff, and you just download the things online to your board with just 5 seconds. So in this way, a lot of people are saying, oh, they have troubles, to configure or to download the IDE tool from the from the manufacturer, or they have a MacBook system. It cannot even support running all of those stuff. So the new version of FPGA solves all the problems those new beginners have occurred. Actually, you just got me because we are about to launch this new version of FPGA on the Kickstarter, probably just in 1 or 2 weeks. So by the time you will see all the details, like why it's different, why it is hassle free for new beginners to learn the FPGA, and why you can learn the basics and the gist of FPGA just probably in 1 or 2 weeks. And this board is also can be used for sort of intermediate or advanced users because it has 4,000 logic units. We even have some companies acquiring our FPGA to integrate it in their own product design. So this FPGA is can be also used in industrial level. Right.
So if I understand right, Daniel, I don't know much about your new project. The main difference between what I experienced with your first generation FPGA and the new one that is going on Kickstarter now is that I used the Lattice software, which looks like this basically. It's just I guess an industry standard editor for creating FPGA applications, which is definitely not the easiest thing to use, right? It's the editor tends to always confuse the beginners like myself and the FPGAs. You have replaced that with your own web-based editor, which is kind of the analog of the Arduino IDE for microcontrollers. So the biggest problem with microcontrollers in beginners is the tools, the software tools to program it. Arduino came in and developed the Arduino IDE to make that part easy. And you're doing something similar, right? You replaced all this complex editing or developing environment with a web-based one that just removes all the complexity, and you can just start designing your application on the FPGA in your web browser. Is that the main difference?
Yes, you're absolutely right. Well, the one we have for the Kickstarter is also available, well, to support the Diamond IDE, because Diamond IDE also has some very advanced tools where you cannot really realize on the web-based browser. But most, I would say like 80% of the stuff you learned in the beginning doesn't require such a complicated IDE system. And that we build our own, more user-friendly IDE with, we eliminated most of the buttons, not you don't necessarily need, just focus on the design itself. Because, the well-learned FPGA, the gist or the key is to focus on the hardware description language, right? Yep. Because you design something on a paper and just use a coding style to describe what you design. So either Verilog or VHDL is the key to learn FPGA. So we got a nice interface similar to the Arduino Web IDE, but it's not that advanced yet. We still need the whole team to just keep fixing bugs all here and there. But to get it using, I've been tested for probably 2 weeks, simply do all of my projects using this Web IDE, and I have no problem with that. So this IDE tool allows you to, just overlook all those complicated, unnecessary stuff as a beginner. Just focus on what you have to the design. And another key difference for the board you receive is to flashing the firmware. So while you design everything ready and you want to program the hardware board, you still have to use the Diamond IDE and configure some COM port stuff and click here and there and to burn the hardware. So for this new board, we configured as a USB flash drive mode. So while you just connect the FPGA to your computer, it just turned out as a USB flash drive, similar as your disk C, disk D, whatever. So you probably have there is showing up you as a step FPGA drive. So whatever the program you are ready, you just drag this file into the USB flash. It automatically finish all the programming burning stuff. So in this way, you just imagine when you design something and you want to share this code to a friend, they don't have to download the IDE to just program this software. You just give them the file that you plug in and you drag this file into the flash drive. It automatically burns itself. It could be very convenient and easy even for industry or product design later on to update or maintain their products.
It's like I do a programming. This is how I program my MicroPython board. Or
MicroPython. Yeah.
If people are familiar with that, you do the same thing. You just drag your little program file on the USB drive, and then the board itself, program itself, essentially. Dan, I'm not sure if you are able to do this now, but do you think you'll be able to give us maybe a quick demo of what this editor looks like on your computer? We could do a screen share if you're set up for that.
Yeah, I can share. Since it will be on the Kickstarter in very, just maybe in 1 or 2 weeks, I want to keep you guys, just allow me to keep you guys in some suspense. But still, I can share some stuff because we still have some bugs here and there. Our team is trying to fix all over the place. But I can share some preliminary stuff that you can get a sense. Yeah, I can just do a share screen.
Yeah, if you could, maybe like equivalent of a blinking LED program, I guess, the standard Hello World program for the hardware world.
Yeah. Okay.
And I'm aware that it's work in progress, so I don't want to put you on the spot here.
Yeah, well, let's just do a share screen. Well, I believe you can see my screen. So yes. Actually, we have, this is not published yet. It's in our back end, hidden in some server. But when you get to here, to program FPGA, you just click start in the web page. So now you get an interface where you can simply just put a project name. Let's say just do some very simple example. Say let's say AND gate, right? So AND gate, we just say AND gate for the name. Select the board. This one is the one you have as the first generation, and this one is the new one we're gonna put on the Kickstarter. So let's say this is choose this board, and we just submit for the project. Well, you see it's getting success, and now you just design your Verilog code here. I would just say AND gate. Keep the same here. So now you're gonna do the this platform supports Verilog. So let's say we just design an AND gate circuit on FPGA with this Verilog. So it always starts writing something like, well, it tests my coding. Well, I have sometimes I just copy paste here and there, but it didn't have time to just type piece by piece. So type like module. I would say just name it whatever AND gate, and then you probably need to define what is the input and output. So AND gate has 2 inputs and 1 output. So I just say input, just randomly name it as A and B, and I just say output as Y. That's basically how the AND gate it is. And now you're gonna describe what's the logic behind. So the Verilog supports all the basic logic gates as primitives. So in this case, you can just say AND and Y, A, B, and then you put AND module, done. So I hope it has no errors. So, but once you finish your coding here, I'm missing this. So once you finish your coding here, you can just click this one. This one is called synthesis, basically converts all of your Verilog stuff into logic gates. Well, I got success, that's cool. So now we got to the pin assignment part here. So while do pin assignment, your board is actually show up here. We support everything as a graphical way. For example, we have 2 inputs, A and B. We want to, visualize what it happens when we tune like A, B, change the variable for A and B. So I just assign that to 2 of my switches here. And you can see while I do this, the switches has been highlighted. Well, this is actually exactly the board, in this way, I think. So this is the board, you can see matches to what you have here. Is kind of like in graphical way. Well, but for the easy, I just use this one. This is like a magnified version just for me. I only myself has it, magnified version for this board. So and let's just observe the output. So I was assign the output to Y, right? So you have 2 inputs assigned on the switch, the output on one of the LEDs. So let's just save, and then you do FPGA mapping. Basically, that way you convert everything you put into the executable FPGA stuff. So you just generate the final executable implementation file. Oh, okay, I got everything working. So now you go to the download step. So this is the key part. So let's say I just plug in the FPGA to my computer USB. I plug it. So you will see it's automatically jump up, an extra disk called step link E drive, right? So this is actually my FPGA. If I unplug this, you see it disappear, right? You don't have to install anything as long as your computer configures a USB drive. So in this way, you just download the implementation file into this step link drive and you save. So once it finished downloading, it automatically burns the software. So we just test if it really works. So we assign these two pins for the input. Let's say if I just change that, you see the first LED is getting so well. If you only this is like a AND gate, right? So if you turn the thing off, right, you will see, well, actually this is the inverted logic. So if it's 0, it means the hardware is you have a logic 1 there. We put that into inverted logic because it saves a little bit more power. So, but the users may take few minutes to just think it through. But you get the gist, right? Everything can be done with the entire IDE system. You don't have to install anything. For most of the stuff, you can run the whole story on this browser stuff. And I just show you probably everything in 5 minutes. So I think that's kind of a feasible tool for the beginners to learn, right?
That's amazing.
So, but I will close that because this is still, we have a lot of bugs there, but you will see the completed version in the Kickstarter.
This would make my huge article about half the size, maybe a quarter, once it's up.
Well, actually, yeah, there is still a big reason why you want to use the Diamond IDE, because in the Diamond IDE or the IDE, launched by the manufacturer, they assign some IP cores. So the IP core is there are, for example, some dividers or some phased locked loop. They integrate all the stuff in the hardware design of FPGA. So other manufacturers or companies, they have no access with that. So using the IDE tool, you can get access to a bunch of cool, amazing IP cores there. So even if our web browser-based IDE does not support that. So for example, if you want to jump this frequency to 400 megahertz, our IDE cannot support that. Yep. The web browser-based IDE only go up to 12 megahertz, but that's basically enough for most of the beginners. But still, yeah. I mean, the Diamond IDE is definitely useful there when they go to more advanced applications.
But step one is like the Arduino IDE is perfect for beginners and a school environment and even makers. I guess myself, I almost use exclusively the Arduino IDE, and I can do pretty much anything that I need to do. So we understand that, of course, the hardware itself is far more capable than what you can do through the web development environment. Then you can jump onto something more capable, like an industry standard editor, like from like the manufacturer of the chip. I think you're using Lattice, right? Lattice Diamond. All your FPGA boards use standardize the actual core, the chip on it, to the one that's made by Diamond. What would be the ideal use for your web interface, for your web development interface for this new board? So, for example, what kind of learning objectives would a student be able to achieve, or a STEM teacher will be able to achieve in his class or her class?
Well, basically, the design we have is we put that into the standard DIP40 design. So basically you can plug that on a breadboard. So essentially, FPGA is just a customizable chip that can be programmed to implement any digital functions you like. Yeah, practically any digital function. So in this way, for example, what you can do with Arduino, you can always replace by the FPGA, and you can, the good thing is for this board, you can just plug into on your breadboard. For example, if you want to, well, actually, we are writing a completely tutorial, maybe 150 pages. covering from the most basics of how the logic gates can be implemented, and to a next level where you can do cool stuff. For example, we add 5 or 6 practical projects such as control an elevator, synthesize music for the pianos, right? Because for FPGA, it has absolutely no problem generating multiple frequencies at once, right? So in this way, you can synthesize multiple frequencies into a nice a nicer sound music and tune that to simulate more like a piano or violin or string music, whatever. You can use this FPGA to do that. And also you have some, the famous 74 series logic gates made by Texas Instruments, right? You can just use this FPGA to design the function of all those chips. So we cover about 50 different chips where you can simply use this FPGA, write the logic behind it, and assign the pins to match, sort of like a design chip. So this FPGA itself can do a lot of stuff.
So you could use this, I guess, even at university level to teach students, say, Boolean algebra, for example. That would be one topic. You mentioned gates already. The 74,000 series of chips, instead of buying individual chips and putting them on breadboard and wiring them up, you could actually do that in your FPGA. You could learn how, say, a computer does mathematics, like create adders, multipliers, converters, so other like basic digital circuits that are part of our digital electronics curriculum. You could replace a whole bench full of instruments and chips with one FPGA board and a web-based editor, right?
Mm-hmm. Yes.
So that you can imagine how that would, I guess, speed up learning and reduce costs as well, the complexity there.
Yes. Yeah.
That's amazing. Right. So you've got that project coming up that I guess that's where most of your time goes right now, and the whole company is towards gearing towards launching this Kickstarter project. Just I'm mindful of our time and I want to fit as much as possible in it. Maybe I'd like to talk a little bit about what happens next for you once you have the new FPGA board out with its amazing editor online. What's your vision past that? What's your next project?
Well, I think the next project, we are already conceiving, but not actually put into a lot of human resource on that, is we want to have an integrated device that combines all the cool features. For example, well, it's more like an enhanced version of Zulark, because after we launched Zulark on the Kickstarter, we received a lot of feedback saying, can you make it more bigger and with higher end of technical specifications, because people are always looking for some gigabytes stuff, right? Megabytes per second, all of the stuff. So they say, why don't you just combine some cool features and make a larger screen and we'll probably put a more capacity battery inside, or either use a PD charger so that the device can be also adapted in university teaching or more advanced engineers for some cool topics. Say when you want to generate maybe 10 megahertz direct synthesis signals. So in this way, we are actually conceiving an idea to integrate everything together into, and we want to design a more industrial level, but still not that industrial, but higher educational level instruments that integrate all those features. That's our one of the plan we plan to do in the future. The other one is we would like to write more, to make the teaching material to be more, well prepared, because for beginners, most of the beginners, they don't care how technical advanced for your product is. They care what they can learn out of it, right? So in this way, they need lots of examples, project ideas, and some videos books, tutorials, whatever. So we'll be focusing on that, right? Some as prepare as much as possible so that beginners can find a very smooth and enjoyable learning process when they first get in touch with new technology.
Great. Looking forward to all that. So if there's those two things, just to make sure that I get it, you're going to improve products that you have already released, like the Zulak. That's a great product. Just make it more capable, more features, higher specifications. And there's always the documentation, which is important for education purpose that you are aiming towards. So I'm looking forward to all that. Okay, Daniel, I think we can leave it at this. We've covered quite a lot of ground. I'd like you to maybe take the next couple of minutes just to explain to people that are listening how they might be able to get in touch with you if they need to, especially what to expect from the upcoming Kickstarter project. I will, of course, keep my audience informed, but maybe there's a place where they can go and sign up to wait for notifications, and anything else that you might want to let people know at this point.
Well, yes, I'm thinking because our team is more like focusing on the product design. Actually, our website, where we don't have a very advanced or user-friendly subscribing system. Well, there is a subscriber function on our website. Well, if you would like to receive notifications, of course you can do that. Now we have a marketing team desperately working on the social media and also some email marketing stuff. So we need some improvements on our marketing team. And later on, if your audiences or people would like to contact us, for now, the best way is just go to our website and send us email. You can just address, I'm talking to Daniel. That's definitely fine. But in the case for the case in the future, we definitely need a more user-friendly system where they can simply get weekly or monthly updates from us. We are actively building that. So as you mentioned, one of our efforts in the future is not only focused on the product design, but also the entire system, including the marketing stuff. Yes, that's also what we did. Because I'm an engineer, and the folks when I gathered in the lab to start a business were all engineers. That's why doing development is our specialty, but now we realized that for running a business, the marketing and the business is also play a equally important role.
Communications.
Yeah, but definitely they can reach us on the Kickstarter and also on our website, or you can click the subscribe button. That is still functional. I'm not saying it's just a pure icon there. It's just we need more operations and marketing to just work through that.
All right. Yeah, I know it's always a challenge. Communications is it can be complicated, but you've got what's needed. So you've got your subscribe email list, I guess, here, and you've got our contact us form. So that should be enough for now. I'm personally going to look out for a message saying that we are up on Kickstarter so that I know what's going on. All right, Daniel, that was great. Thank you for your time today and for demonstrating the new amazing FPGA board that's coming up. I'll be looking forward to getting one and playing with it. I'm particularly excited about the use in education. Of course, this is digital electronics because that is one of my both education and personal hobbies. So I want to see how I can apply it there. And I'm looking forward to having you again soon on our podcast to talk about your next projects.
Yeah, of course. I will be also looking forward to talk to you next time. And I think I will be back to Vancouver, Canada in late of this year. So maybe I will talk to you while I was in Vancouver and pick a nicer place.
Perfect. Thank you, Daniel. So have a good day.
Thank you.